Exploring loops in Python. They are the essential structure that allow your code to repeat actions and process data with minimal effort. We will cover four key loop structures in Python. For loops, which are perfect for iterating over sequences like list, strings, or ranges of numbers. Next, the while loop, which continue executing as long as a specific condition remains true. Nested loops, where we place one loop inside other to handle multi-dimensional data or complex iterations. And finally, break and continue statements, which gives the precise control over the loop execution. For loops are designed specifically for iterating over sequences like list, strings, or ranges of numbers. They provide a clean symbol syntax that makes working with collections intuitive. In our example, we use the range function to create a sequence of numbers from 0 to 4. The for loop automatically assigns each value to the variable I and execute the intended code block for each iteration. While loop continue executing as long as a specified condition remains true. They are particularly useful when you don't exactly know how many iterations you will need in advance. In the example, first we initialize a counter variable. The while loop checks if the counter is less than 5 and if so, executes the code block. We make sure to increment the counter each time to eventually exit the loop. The nested loops are loops inside other loops, creating a powerful pattern for working with multi-dimensional data. They are commonly used when processing matrices, tables, or when you need to check combination of items. In this example, our outer loop runs 3 times with I values from 0 to 2. For each of these iterations, the inner loop runs twice with j values 0 and 1. This creates a total of 6 iterations, printing each combination of I and j. Finally, let's discuss the break and continue statements. These keywords give you the precise control over the loop execution. Break exits the loop completely, while continue skips the next iteration. In the first example, we iterate from 0 to 9. But when I equals 5, the break statement immediately exits the loop. In the second example, the continue statement skips the print instruction whenever j is even, resulting in only odd number being printed. Mastering the loops allows to efficiently process data of any size. They provide essential control flow in the programs, making the repetitive task concise and readable.